the main objective of this session is that the objective of this lab activity is to perform hand-on experiment with the help of multimeter and breadboard. And what you learn from this session, so student will be able to understand about multimeter, and student able to know about how to measure resistance, DC and AC, and student able to examine transistor testing. So all these things you learn in this session. So now I start my session by using a multimeter. So do you know about what is multimeter, beta? And how to measure various quantity with the help of multimeter? Do you know about this thing? Please send me your response. Okay, this concept is new to you. Very good. So here, beta, this is our multimeter. So what is multimeter? As the name indicates, multimeter. Multimeter. So what is multimeter? As the name indicates, multi means many. Okay, so multimeter is a device that is used to measure multiple quantities on a single scale. So multiple quantity means we measure voltage, current, resistor, okay, and DC voltage, DC current. So all these things we can measure with the help of an instrument, and that instrument is named as a multimeter. Okay, so now the question arises, how we measure it? How we measure? Okay, so here you see that in the multimeter we have two wires. So these two wires of the multimeter is actually named as probe. This is named as a probe, multimeter probe. These two wires is named as probe. Always keep in your mind. Okay, so here you see that we have a red color wire and the black color wire. So red color wire is used for positive, and black color wire is used for the negative. Right? Now is this thing clear to you? Red is for positive and black is for negative. But this is the color coding. Okay, you always keep in your mind, because this is a hand-on session, and if you grab this thing, okay, so you don't feel any trouble in coming experiments. Now is this part clear to you? Please send me a response. Very good. So now we coming on how to measure the resistance. So in the multimeter screen, you see that this scale. You see that this scale. But this scale is for the resistance. Having value varies from 200 ohm to 2000 kilo ohm. This is scale. This scale is for the resistance, and having value varies from 200 ohm to 2000 kilo ohm. And here you see that this one is the multimeter knob. This one is named as multimeter knob. Right? So by adjusting this knob to this point, to any one of the point, okay, by adjusting this multimeter knob to any one point, and after adjusting this knob to any point and placing the multimeter probe onto the resistance terminal, we get the value on the multimeter screen. Now get it? Now is this part clear to you, bete? Okay. By adjusting the knob of multimeter, by adjusting the knob of multimeter to any one of the point on the scale, okay, and after adjusting the knob, placing the multimeter probe across the resistance terminal, we get the value onto the multimeter screen. That what is the value of the resistance. Now is this thing clear? Now the next thing is how to measure the DC voltage. Here you see that this is the symbol for the DC voltage. This is the symbol for the DC voltage, having a straight line and after that a dotted line. Okay, because we know that DC having a constant voltage, constant amplitude. DC have a constant magnitude like this. Okay, so in order to measure the DC voltage, we adjust the knob and set the knob to any point. Suppose if we want to measure the voltage of in the range of suppose 20 volt or 25 volt. Okay, so how we set the knob to which point? If we want to measure the voltage, suppose in the range of 150. So at which point we set the knob? Yes, give me answer. Yes, bete. We have to set the knob to 200 volt. 200, not 20 or 200. We have to set the maximum point. Okay, if we want to measure 150 volt, so we have to select the maximum point 200. Okay, greater point we have set, right bete? So after selecting the knob to 200 volt and placing the multimeter probe onto the battery terminal, we get the value onto the multimeter screen, right? So how to measure the value? For this I will show you a video, demonstrative video in our next session. So this thing will be more clear to you when you watch this video. Okay, beta. So now the next thing is, if we want to measure the AC voltage. So if you want to measure the AC voltage, so this is the symbol for the AC voltage. Here you see that we have a symbol like this, having changing magnitude. So we know that in our home appliances, we get the voltage in the range of 220 volt. Okay, so in order to measure the 220 volt, we set the knob of this multimeter to 750, and after that placing the multimeter knob onto the socket, we get the value onto the multimeter screen, right? And yes, beta, is this thing clear to you? How to measure the AC voltage? Yes. So now the next thing is, can you please tell me this symbol is for what? Yes, Vipul. Bete, in our home, we get the value of the AC voltage in the range of 220 volt. So in order to measure the 220 volt supply, we set the multimeter knob to 750 because the supply we have greater than 200. Okay, so greater than 200 we have 750. We set the knob to 750. Now is this thing clear? Now you please tell me this symbol is for AC current or DC current? Yes, please. AC current or DC current? Very good. This is for the DC current. If we want to measure the current in the range in DC, so we set the multimeter knob to this point, okay, and placing the multimeter knob onto the battery terminal, so we get the value of the current. Okay, right beta? So now the next thing is this one. This symbol is for checking the continuity of the wire, or if you want to check the wire is proper or not. So we set the multimeter knob to this point, and after that placing the multimeter probe onto the wire terminals. So after placing the multimeter probe onto the wire terminal, after placing it, if the multimeter sound beeps, that means wire is properly conducting. And if the beep sound not comes, so that means the wire is defective. Right, Betty? So this is all about the multimeter introduction. Is this part clear to all of you? Any doubt you have, please tell me. Okay, beta. So now the next thing is resistance. So this is our resistance. But when we place the multimeter probe across the wire terminal, if the wire is okay, so that means it beeps. When wire okay, then multimeter sound beep. Okay, in the end, if the wire is defective, so the multimeter sound not beeps. So this is our resistance. Okay, so and if we want to measure the resistance value onto the multimeter screen, so set the multimeter knob to the resistance scale, and after that placing the multimeter probes across the resistance, and like this we get the value of this resistance onto the multimeter screen. Okay, so this is the method how to measure the resistance value onto the multimeter screen. So here you see that in this figure how to measure the resistance value. So we set the multimeter knob to the point given onto the multimeter screen, and after setting the multimeter knob to any point and placing the multimeter knob across the resistance terminal, so we get the value onto the multimeter screen. It may be any value, right? So how to measure the DC current? So in order to measure the DC current, we know that the battery is a source of DC current. We get the current from the battery. Okay. So in order to get the value of the current, we set the multimeter knob to the this scale. Okay. And after that, placing the multimeter knob, placing the multimeter probes across the battery terminals, so we get the value onto the multimeter screen. Right, Vijay? Now is this thing clear to you? So now the next thing is how to measure the AC voltage. How to measure the AC voltage? So in order to measure the AC voltage, here you see that we have we set the multimeter knob to any point greater than 220, because in our homes we want to measure the 220 volt, right? So set the multimeter knob to greater than 220 volt scale. Here you see in this multimeter, we set the multimeter knob to 400 value, and after that, no, bete, this is not done by assumption, because the value of the we always choose greater than value. Okay, it is assumption. So after placing it, we set the multimeter probes onto the, we put the multimeter probe to the socket, and after placing the multimeter probes to the socket, we get the value onto the multimeter screen like this. Okay, so in AC supply, we don't have any polarity issue. We set we place a multimeter probe to any one of the socket. In the DC supply, we know that battery is a source, and we in the battery we have positive and negative. In the battery we have positive and negative terminal, so that in order to measure the DC voltage, we place the multimeter probe to these 2 points of the battery terminal. And in the AC supply, we have a phase and neutral. We have phase and neutral terminal, and in order to measure the supply, AC supply, we set the multimeter probe, one probe to the phase and another probe to the neutral. So after placing these two, we get the value of the AC supply. Yes, but now is this thing clear? How we measure the AC voltage? Hurry up, give me answer. Vipul, beta, in order to measure the DC voltage, we have a battery is a source of DC voltage. Okay, so in order to measure the DC voltage, we have a positive and negative terminal on the DC battery. And if we want to measure the DC voltage, we place the multimeter probe to the positive and negative terminal of the battery. After placing the probes to the positive and negative, we get the value on the multimeter screen. And if we want to measure the AC voltage, so in the AC, we have phase and neutral points on the socket. And in order to measure the AC voltage from the socket, we place the multimeter probe, one probe to the phase and another terminal to the neutral. So after placing this, we get the value onto the multimeter screen for the AC voltage. Now is this thing clear, Vipul? So now the next is transistor. What is transistor? So transistor, we know that we have a uh, common emitter, common base, common collector. So these are our type of the transistor. Okay. So transistor is basically a three-terminal device: emitter, base, and collector. Here you see. So this is the symbolic representation of the transistor. Here you see, and this is the pictorial view of the transistor. And in this pictorial view, you see that here a flat portion. This is a flat portion, and this one is the curved portion. Okay. So in order to measure the transistor, we always keep the flat portion of the transistor to the upper side. Okay. So how? Here you see that in the multimeter, we have a option for measuring the transistor. So we always, in order to, we know that transistor is of two types, PNP and NPN transistor. And in order to check that transistor is which type, means transistor is NPN type or PNP type, so we always keep the flat portion to the upper side of the scale and place it in the first three slots like this. So after placing the transistor to these slot, if we get the reading onto the multimeter screen, so that means this transistor is our NPN transistor. And if we don't get any reading onto the multimeter screen, so that means that transistor is our not NPN transistor, that is our PNP transistor. Okay. Yes, beta. Now is this thing clear to you? How we identify that which transistor is our NPN or which transistor is our PNP? So in the multimeter, here you see that these holes. Here you see that these holes. But this hole is for the for connecting the red wire, and common is for the black, means neutral. But if we want to measure the voltage, we place the red wire into this hole, and if we want to measure the current, we place the red wire into this hole. Okay, so common wire means black wire is always placed into this hole. We change the red wire but not the black wire. Black wire position is fixed and red wire position is changed as per requirement. Means if we want to measure the voltage, we place the red wire into this hole, and if we want to measure the current, we remove this wire from this hole and place into this hole. Yes, is this thing clear? So now the next thing is our breadboard. But a breadboard is one of the most important thing that we have to understand, because if we not don't know about the breadboard, we don't do anything in the BEEE lab. Okay, so what is breadboard? But a breadboard is used for making the connection. Okay, so here you see that in the breadboard we have a upper and the bottom layer. So the upper and the bottom layer is for the horizontally shorted slots, where the teeny holes are internally horizontally shorted. Okay, like this. Teeny holes are internally horizontally shorted, like this. The upper and the bottom layer are internally horizontally shorted, and the middle slot are internally vertically shorted, like this. Now understand? Yes, beta. Now is this thing clear? Okay. So now, if we want to design any circuit, suppose we have a circuit like this. Suppose we have a circuit like this. So can I design this circuit on the breadboard? Can we design this circuit on the breadboard? So how we design this? So in order to design this circuit, suppose we connect the resistance like this. We connect this resistance, placing the one leg of this resistance to this slot and another leg of this resistance to this slot. Okay, and in order to connect the this resistance, so how we connect this? We place the resistance. Yes, beta. Now is this thing correct or not? Yes, please tell me. Is this thing right or wrong? Is the continuity of the current? Hurry up, give me answer. Why this is wrong? Because we don't make the continuity. Okay, so in order to make the continuity, we make the proper joints like this, right beta? So in order to connect the third resistance, so we connect the resistance over here and the second leg of this resistance to the horizontally shorted slots like this. We connect the resistance third, one leg of this resistor to this point and another leg to the horizontally shorted slots. So in this manner we make the connection. Okay, so we know that where the 3 points of this resistor is connected. This is named as a node. Okay, and now if we want to connect the battery, suppose this is a positive terminal of a battery and this is a negative terminal of a battery. Okay, and in order to connect the battery, so we take a wire from the positive end of the battery, connect to this point, and the negative terminal of a battery is connected to the horizontally shorted slots like this. So in this manner, we make the connection designing on the breadboard. Yes, beta. Now is this thing clear to you? Hurry, beta. Give me answer. If you have any query, please tell me. Beta, ground is not connected. Jatin, we don't. Supply. Okay, beta. So this is all about the designing part on the breadboard. Same thing is mentioned over here when we design the circuit, this type of series circuit on the breadboard. Here you see, we place one resistor over here. Okay, we place second resistor over here. We place third resistor over here. And in order to connect the battery, we use the this terminal. We connect the positive end of this supply and we connect the negative end of the supply. Okay, so although we use vertically shorted slots and horizontally shorted slots together to make the circuit, okay, we always use these two connection, these two ports continuously in order to design the circuit. Okay, so this is all about the connections that we have to design on the breadboard. Yes, beta, now is this part clear to all of you? Any doubt you have, please tell me. Yes, beta, now do you have any account on the Tinkercad? Do you have account on the Tinkercad? You already perform experiment on the Tinkercad, beta? Which experiment you perform on the Tinkercad? Which experiments you perform on the Tinkercad? Okay, you perform digital electronics. Okay, okay, very good. So now, bete, as I want to tell you one question in this lab regarding the elements. Now, you please tell me, resistance is unilateral element. नो प्रॉब्लम बेटे विपुल, मैं आपको बेसिक से ही करवाऊंगा. You don't worry about this. So now please give me answer. Resistance is unilateral element or bilateral element? Hurry up, 10 students have no response bete. I repeat, 10 students have no response. So the resistance is not a unilateral element. It is a bidirectional element. Okay. And my next question to you, capacitor is active element. Hurry up, beta, hurry up. 10 students have no response. One more thing I want to tell you, please be active in my class. I give you marks according to your class performance. Okay? So please be active. So capacitor is not an active element. Okay? Capacitor is not an active element, it is a passive element. Okay? And also it is an energy storage device. Right, Bete? So now the next question to you. Next question to you. So now the next question to you, what is linear element? Your option is which shows linear characteristic and which have non-linear characteristic. Very good. This question is obviously the characteristic, the device which shows a linear characteristic, that is named as linear element. Very good. So the answer is first. So now the time for the session is over. You may please leave the session and join the session on 3:45. Okay? And how you feel in the session? Please make a face impression and please left. I think you grabbed a lot of things in this class. And how you feel? Please make a face impression.